Hello everyone. In this second video clip, I'm gonna introduce to you guys some basic trig functions. It is sections 1.3 and 1.4 in our textbook. The 6 basic trig functions are sine, cosine, tangent, cotangent, secant, and cosecant. We're gonna start our clip today with a right triangle. Again, a right triangle is a triangle that has one angle equal to 90 degrees. Okay? And let's call this side right here is C. This is A, B. We have a very famous theorem about right triangle called the Pythagorean theorem. The theorem says what? If you have a right triangle, then the sum of the squares of the two sides, and here is a squared plus b squared, gonna be equal to the square of the third side, which is called the hypotenuse. Right? This is a very famous theorem called Pythagorean theorem. It's on Pythagoras. A squared plus b squared equal to c squared. Hypotenuse squared is equal to side a squared plus side b squared. Okay? Now, is the very first thing that we start with our section today. Okay? Now, let's call the angle right here is angle theta. Theta is a Greek letters. It's like letter T in our ABC alphabet. Okay? And uses our tradition to denote angle and trigonometry using Greek letters. So I was just on that tradition called angle theta. Okay? So what we're going to learn here is 6 basic trig functions. We know this way. Sine theta, cosine theta, tangent theta, cotangent theta, secant theta, and then cosecant theta. Cosecant, you know, the CSC, cosecant theta. Okay? Sine is calculated. Sine of this angle, it's just trig function, right? I'm about to introduce you. Is B over C. And in short, it will make it easy for us to remember. Used to people say what? Opposite over hypotenuse. Obviously, C is the hypotenuse. Opposite means what? The side that is right opposite of the angle, right, is B over C. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. A right here is adjacent, right next to the angle theta. So A over C. Tangent theta is opposite over adjacent. It's B over A. And then cotangent theta is the reciprocal tangents, adjacent over opposite, which is A over B. Okay? Secant is the reciprocal of cosine. It's going to be hypotenuse over adjacent. C over A. And similarly, cosecant is the reciprocal of sine. It's going to be hypotenuse over opposite, or C over B. So basically, in our entire course, we're going to play around with those basic 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. We introduce you by starting with the right triangle. Okay, and we have it. Now let's move on. Let's extend the concept a little bit more. Okay, we have 6 basic trig functions ready. We're going to extend our concept a bit more because our theta in this triangle is an acute angle. And actually the trig function works for any kind of angle. Could be acute, could be right angle, could be obtuse angle, any kind. So we're going to extend the concept a little bit more. Now, let's start with the xy coordinate, Cartesian coordinate. Okay? what if I have a point P? Point P. X comma y on the plane. Okay? It's like a point P right here. Okay? Point P, x, y means what? From the origin to this point right here is x, right? The distance from here to here is x. Similarly, distance from here to here is y. In other words, this side right here is y. If I draw a right triangle, that length right here is, how long is that? X. The length right here is y. Of course, this angle is 90 degrees. Of course, that line right here is going to be the hypotenuse. And people use denote by r. R means radius. Okay? And let's call this angle theta. And very similar to the right triangle that we had before, sine of theta can be calculated at what? Sine is opposite over hypotenuse, so y over r. Cosine of theta is adjacent over hypotenuse, which is x over r. The same thing, tangent of theta is y over x. Cotangent of theta is x over y, the reciprocal. And then secant of theta, reciprocal cosine, so r over x. And cosecant of theta is a reciprocal of sine, so r over y. And of course, the Pythagorean theorem also applied here. It means x squared plus y squared is also equal to r squared. Okay? The reason why I tried to bring it up into the point on the xy coordinates right here, because I want you guys to understand the concept a little bit more. The point P may not be on the first quadrant. Okay? The point B may be on the second quadrant, the third quadrant, on the fourth quadrant, and I claim that. You guys can apply the same way to calculate the trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. For example, let me give you a very specific example. Apply the same idea, so I'm going to keep the first picture in here a little bit longer. Say I got a point P right here. And this point P is at -1, 2, for example. X right here is -1, y right here is 2. Right? Means x equal to -1 and y equal to 2, right? And you know what r? R is, or square first. It's -1 squared plus 2 squared, which is 1 plus 2 squared is 4, equal to 5. So r is √5, okay? This is r. R equal to square root of 5. We can apply the same exact 6 strict formulas to calculate sine, cosine, tangent, cotangent, secant, and cosecant. All right, let's see what you got. Sine of theta, this angle right here, theta, guys. You see that this angle now is more than 90 degrees. It's an obtuse angle, right? It's the x-axis right here. Origin is right here. Y-axis is right here. So sine of theta is going to be y over r. Y over r. Y is 2. R is √5, right? So 2 over √5. And usually people don't want to put radical on the denominator. To me, it's fine. You can write it this way. That's totally okay with me. But if you want to rationalize it, you're going to multiply the top and bottom by √5. You're going to have 2 square root of 5 over 5. Either way of writing are the same to me. Don't make any difference. And then cosine of theta is going to be x over r. Now, x is not a positive number anymore because the point P is on the second quadrant. So x is -1 over square root of 5. And again, you can either leave it this way or rationalize this. You got -√5 over 5. Okay? Similarly, you can calculate tangent, cotangent, secant, cosecant, apply those formulas. And it's in here. You see what? If the point P on the first quadrant, then cosine is positive, like the x positive. Sine is positive because the y value is positive. But if the point P is on the second quadrant, what happened? X is negative. The y is positive, right? x go along with cosine, y is associated with sine. So cosine will be negative, sine will be positive. Same idea, what if you have a point P on the third quadrant? Now what? Both x and y are negative numbers. And that means both sine and cosine will be negative. And if you have a point on the fourth quadrant, then what? X will be positive, which means cosine will be positive, but y will be negative, that means sine will be negative numbers. Okay? And we still have six trig functions work all over the plane. Doesn't matter what kind of angles you have. And remember what we have for coterminal angles. It works the same way. If you have an angle, say, from here to here, you go around one more round of 360, you're going to have the same trig functions values. Okay? Now, let's talk about some basic identities for trig functions. Okay? We're actually moving on to section 1.4. Still about trig functions, but they show you some trig identities. Okay? Let me keep the 6 trig function right here. I'll work with it. Recall that by Pythagorean theorem we have x squared plus y squared equal to r squared before. Alright? What if I divide both sides by r squared? I'll have what? X squared over r squared plus y squared over r squared equal to 1. And you know what that is? X over r is cosine. So x squared over r squared is cosine squared of theta. And then plus y over r is sine. So y squared over r squared is sine squared theta. Okay? So we have the very first trig identity. And of course, and I bet you guys are going to see this over and over through the course. Or whenever you learn trigonometry, you see this. Cosine squared plus sine squared is equal to 1. It is just like the Pythagorean theorem in trigonometry. Alright? That's the first one. Second one. You guys see tangent and cotangent? This tangent is y over x. Cotangent is x over y. So one is the reciprocal of each other. So cotangent of theta is the reciprocal of tangent of theta. This is another trig identity. Now, what about secant and cosine? Cosine is x over r. Secant is r over x. So obviously, secant of theta is the reciprocal of cosine of theta. And similarly, cosecant of theta is equal to 1 over sine theta. Okay? Those are the very first basic trig identities that you guys are going to see in our course. Very good. Okay, let me derive the formula a little bit more. Let's start from this. Cosine squared plus sine squared equal to 1. Let me erase the quick one here. We have cosine squared of theta plus sine squared theta equal to 1. I'm going to show you or help you derive more trig identity using this one. Now, what if I divide both sides by cosine squared? Divide both sides by cosine squared. Okay. Cosine squared divided by cosine squared is 1. And what about sine squared divided by cosine squared? Forgot to mention that. Let me see in here. Cosine squared of sine squared divided by cosine squared, we can calculate it in here. Sine theta is y over r. Cosine is x over r. So y over r divided by x over r divided by fraction means multiplied by its reciprocal. So this is y over r times r over x. See that r over x is the reciprocal of x over r. R cancel out. This is y over x. You know what is y over x? Which is tangent of theta. And we actually have another trig formula in here. Let me just write down here. sine of theta divided by cosine of theta is equal to tangent theta. This is another one. This pretty basic one. Okay, so this is 1 sine over cosine is tangent, so sine square over cosine square is tangent square theta, and equal to, what about 1 over cosine? We learned that before. 1 over cosine is secant, so 1 over cosine square is secant square theta. Alright, so if sine over cosine is tangent, reciprocal of this is going to be cosine over sine, and guess what? It's going to be cotangent, right? We're going to have another formula. Look, by similarity, what if I divide both sides by sine square? Cosine divided by sine is cotangent square, so cotangent square. Sine square divided by sine square is 1. It's equal to 1 over sine square. Reciprocal of sine is cosecant. Okay? So you guys got some basic trig identities that you guys are going to need to use constantly during the course. Let me summarize those for you. Okay? Put all the identity in here before I grab. Well, I stop the video clip today. Basic one. Sine square theta plus cosine square theta equal to 1. Divided both sides by sine square. I got 1 plus cosine over sine square is cotangent square theta equal to cosecant square theta. Divide both sides by cosine square. I got tangent square theta plus 1 is equal to secant square theta. Okay. Sine theta over cosine theta equal to tangent theta. Alright. Reciprocal of this, cosine theta over sine theta equal to reciprocal tangent, which is cotangent of theta. Alright. Secant of theta is 1 over cosine theta. Cosecant of theta is equal to 1 over sine theta. And that's pretty much what I want you to have for this sections that we cover today. Thank you very much.